Sophie, which one are you doing? Okay. Do you have some assignment due for chemistry?
No, but we have for AAC.
When's that due?
This Friday. But I'm leaving on Thursday, so coming in this Sunday.
Is the physics homework taking a hit?
A slow hit.
Oh dear. Alright. Okay, Irene, can you give me the first question? What did I ask you to do?
Convert 2.5 EV into J.
2.5 EV is 2.5 times 1.6 times 10 to the minus something, I forgot.
10 to the minus 19.
Yes. So what did you get here?
4 times 10 to the power minus 16.
Yeah? Yeah. Alright, the second one, what do you want?
Convert 1.5 nanomoules into EV.
Okay, so that'd be 1.5 divided by 1.6 times 10 to the minus 19 times 10 to the minus 9, which equals into EV. Nine point three six giga electron volts. That's okay, isn't it? Alright, so when you finish eating your porridge there, give me number 3, please.
What is the potential energy in EV of a photon, which is equal distance between two parallel plates separated a distance of 1 millimeter with a potential difference of 9 volts?
9 volts?
Yeah.
And it's right in the middle. Yeah. So the potential energy is QED. That would be 1.6 times 10 to the minus 19. Now the E is V over D. But just be careful, the D is not 1 millimeter, it's half a millimeter. So QE is V over D, and the D is a half a millimeter times the total distance. Well, actually, sorry, I have that backwards, I'm sorry. The D at the end here, maybe that should be a H if you prefer. That's this part here. The E here is V over D. And the V is 9. So this will cancel with this, and here we get here we get 4.5 times 1.6 times 10 to the minus 19 joules. But how big is this part here? That's 1 electron volt. So in fact the answer is 4.5 electron volts. Yeah, I wasn't being very clear. This is the D, but I should really call that small d or H QEH, I think will be better. This is like the height. And the E is V over D. Many more questions are there?
Two more.
Okay.
Three more.
Can I scroll down? Right, what's next?
How fast would the electron be traveling if it leaves a negative plate and strikes a positive plate which is 2 cm away, and the distance traveled has a potential difference of 12 volts?
So the potential, and what's an electron?
Yeah.
Potential energy equals kinetic energy. QEH equals a half mv squared. So 2 QEH over m square root equals V. So V is square root 2 times 1.6 times 10 to the minus 19 times this EH part here, that would just be 12 over then the mass of an electron, whatever that is.
What is the EH from?
Well, E is V over D, and the distance is yeah. Mhm. So it will be 2055 kilometers per second. Okay, what's next?
How long will it take for a proton to travel from a positive plate to a negative plate if the distance between the plates was 1 millimeter and the voltage of the cell connected to the plate was 25 volts?
How long? Okay, so I'll do it the same way again. Kinetic energy equals potential energy. A half mv squared equals QED. Is it an electron?
Proton.
It's a proton. So when you solve this, you get V equals hang on, I retyped that. Two 25 mass. Yeah, this here will be 69.2 kilometers per second. But that's not what I want. I want, is it the time?
Yeah.
Right, so we have to do it as a U, V, A, T. Yes, the U is 0, the V is 69206, the A we don't know, the S is 0.001. So I think I'll use S equals U plus V over 2 times T. So when you solve this, you get T equals 28.9 nanoseconds. One more? Okay, what's the last one?
A battery of EMF V is connected to two horizontal and parallel plates. One plate becomes positive
Yeah.
and one plate becomes negative.
Yes.
An electron is fired at 45 degrees above the negative plate at a speed of 1 kilometer per second, which lies flat on the ground, onto a field under the positive plate. The distance between the plates is 10 centimeters. The electron is about misses the negative plate above it. The electron then falls back down to the positive plate. What is the EMF V?
Sorry, this is the negative of the top, and this is the positive. So this is the positive, and this is the negative. And you said the electron is fired at what angle? 45?
45 degrees.
So the electron is fired at 45 degrees, and it just about misses the negative plate, isn't it? And the question is, what's the E it must be, is it?
What is the EMF V?
The V, sorry, that's the V, well, E, whatever, it doesn't matter. The EMF is equal to V volts. Right, so if you look at the horizontal and vertical here, and we call this, I don't know, do I give you the firing speed?
Yeah, 1 kilometer per second.
1000 then. So this would be 1000 cos 45, and this one here would be 1000 sine 45. So this is actually a type of projectiles. And let's look at the vertical. U, we know. V, we know. What's the V up here vertically? When it's at its highest? 0.
Oh, right.
Right? The A?
0 as well.
Not this time. The A we don't know because what's pulling it down is the force QE, not gravity. So we don't actually know it here. The T, we don't know. The S, we do know. 0.1. What would I like to know? I really would like to know the A. So I can say V squared equals U squared plus 2AS. So here I get A will be minus, if you want, 25,000,000 meters per second squared. So then the F equals MA. Is this an electron or a proton, Harry? Electron, is it? So I get now 2.28 times 10 to the minus 24 newtons. What's another formula for F?
F equals something over
QE perhaps? So QE equals this. Now do I know the Q? I do. What is it? It's 1.6 times 10 to the minus 19. So the E is 1.42 times 10 to the minus 5 newtons per coulomb. What's the formula for E?
V over D.
Yeah, so V over 0.10 equals 1.42 times 10 to the minus 5 newtons per coulomb.
So the D, you take the whole thing.
Yeah, vertically. So finally, V equals 1.42 microvolts. Oh, can't quite see that. Is that okay? They like to do this in the exam. They like to mix mechanics and fields. Can I talk to Serena?
Yeah.
Are you sure? Yes? 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 Yeah?
Yeah.
Okay, let's have